So yeah, welcome to my talk, Domain-Driven Design, Identifying and Bounding Context. I apologise if I say Domain-Driven Development instead. They all have the same acronym, so just a correction if I do say wrong. So yeah, we'll just go through an outline of the talk. Hopefully it's not too boring today. So we'll talk through monoliths, a bit about coupling cohesion, what is domain-driven design, the strategic domain-driven design, what is a ubiquitous language, the bounded context, patterns on decomposing the application to actual services, the obstacles that come about doing this work, conclusion, and finally a Q&A. So, why has EchoBox become monolith? And before we talk about that, probably a good idea to decide to explain what a monolith is. So a software system is called a monolithic, if it has a monolithic architecture in which functionality, distinguishable aspects, for example, data input, output, data processing, error handling, user interface are all interwoven, rather than contain architectural separate components. The application started off relatively small, and naturally a monolithic system was a simple solution in the first instance. As you can see, it was simple to develop, easy to make new changes, easy to test, easy to deploy, and easy to scale-ish. It was all about building it easy and fast as possible. So here's a nice little overview of EchoBox's monolithic architecture. So you see the user uses the front end. The front end interacts with web service, which interacts with this sort of big box of EchoBox. Job queue is in there somewhere, and then it has this data persistence layer, which data gets persisted from job queue and EchoBox. So you see, it's a relatively simple diagram. We contain some of the issues of monolithic architecture by moving over to job queue, and we no longer share one database cluster for all of EchoBox. Now split some stuff up into their own sort of clusters, so it's good, but as you may have had this term already, we're heading towards a big ball of mud. And everyone throws around all the time, so I thought I'd put it in. And we should start separating out the code base, especially lib, as it's becoming a big ball of mud. So why is monolithic architecture so bad? Well, it causes tightly coupled software and presents the biggest difficulty when teams are looking to extend or change systems. When we want to expand as a team, it might become sort of more difficult to actually make changes, tests, introduce people to the system, etc. When a system gets too monolithic, we end up in so-called monolithic hell. And again, that's the term that kind of people throw around. I have a nice, I don't know if relevant diagram to, to have this explained. So how does monolithic hell happen? The code base is growing larger, the application becomes too complex, it's too large for any developer to fully understand and make mistakes in the environment. I mean, I don't even understand auto-completing, I use it like this, so. The deployment is long and painful. You think about Jenkins, you have to wait for something to build, and then build yours again. It doesn't really make sense, and then it takes maybe half an hour to actually get build and to be merged and then deployed, so it takes quite a long time. We have difficulty in scaling, so requirements of application differ, i.e. some places need different databases, different CPU needs. Delivering a reliable monolith is challenging. Application testing is hard the larger the code base. It lacks fault isolation because all modules are running within the same sort of process. It's kind of like split up in job queue, but still most of the process still run within a same process. We're locking ourselves into an obsolete technology stack. It's hard to adapt to new frameworks and languages, expensive to rewrite everything, put it into a new stack in the case you want to use a new language or a new technology, and the cost of change and experimentation is high. So we'll just go through some of the basics to kind of get our head around, a nice refresher on some of these topics that will come into play later. So we'll talk about coupling. So hopefully all you guys know, but we'll just go through it quickly. Coupling is the measure of degree of independence between modules. As you can see from this diagram, ideally we want low data coupling. So the top is low and then bottom is high. So you've got the extremes of, so for example, data coupling. The dependency between modules is based on the fact that they communicate by passing any data then the modules are said to be data coupled. In data coupling, the components are independent to each other and communicating through data. Module communication don't contain any so-called tramp data. But on the reverse end, we want to avoid any content coupling. And in content coupling, one module can modify data of another module, or control flows pass from one module to another module. This is the worst form and should be avoided. If you want me to explain the other ones, you can ask me later. And then, again, cohesion, hopefully you guys already know. Basically, cohesion is the internal glue that keeps the module together. A good software design should have high cohesion. So we'll look at the extremes. So we have coincidental cohesion, which is like the worst form of cohesion. The elements are not related. The elements have no conceptual relationship other than the location of source code, and it's accidental and it's the worst form. So for example, just bits of tool code like print the next line, reverse characters in the string, etc. You shouldn't have these. And then the best kind of cohesion is functional cohesion. Every essential element for a single computation is contained within the component itself. Functional cohesion performs the task and functions is the ideal version of cohesion. And we have the other ones in order of high to low. Again, you can ask me if you want me to explain further. So therefore, we want low coupling and high cohesion. All interaction with the service happens via its API, which encapsulates its information details. This enables the implementation of the service change without impacting its clients. Loosely coupled services are key to improving application development time attributes, including its maintainability and testability. They're much easier to understand and change and test. So remember, low coupling, high cohesion is the way forward. So, so what do we do? Microservices to the rescue. We want to avoid becoming a big ball of mud in the end of the day. Before we talk about breaking the monolith, let's look at some other fundamentals. What is this? What am I talk about? Domain-driven design, or as you say, DDD. Don't get confused with design-driven development, because I always say it the wrong way around. So what is domain-driven design? It's an approach to software developed for complex needs by connecting implementation to an evolving model. The premise of domain-driven design is placing the primary focus on the core and domain logic, basing the complex design on the model of the domain, initiating creative collaboration between technical and domain experts iteratively to find a conceptual model that addresses the particular domain problem. And this should sort of lead to low coupling, high cohesion. And the model should be its own sort of domain, and we'll look into that a bit further later. Back to okay. So another thing you'll hear a lot when you look about domain-driven design and found context is this thing called ubiquitous language. And it's to allow the fluent sharing of knowledge, domain-driven development, domain-driven design calls for cultivation of shared business domain-oriented language, a so-called ubiquitous language. The language should resemble the business domain, its terms and entities and processes, and it should be extensively used throughout the project. The so-called code should speak this ubiquitous language. All communication should be done in the ubiquitous language and all documentation should be formulated around it. The ubiquitous language becomes the model of the business domain implementing the code. So everyone should use, well, the words should all mean the same things and everyone should understand and what this sort of ubiquitous language is within this sort of domain. Someone shouldn't have the same, for example, does an article have the same meaning in all domains? You could say, someone could say an article is an article that comes from RSS feed, but someone else could say, oh, an article is an auto-feed article. Do they mean the exact same things for one person versus the other? So we need to ensure that they both mean the same thing within the same domain. So we'll look at a strategic domain-driven design. So you'll see this thing floating around called a bounded context. Bounded context is a central pattern in domain-driven design. It's focus of domain-driven design strategic design section, which is all about dealing with large models and tubes. And I'll go into that a bit further in. There's a couple of other ones that are quite interesting. We've got continuous integration, which we want to merge code on other implementation artifacts quickly, with automated tags to test and flag fragmentation quickly. And then finally I'll go into a bit more detail as well about this context map, which is a way to identify these boundary contexts. And you identify each model and player on the project and find its boundary context via the so-called context map, and it's a good way to identify these. So, a boundary context defines the boundaries of the biggest services possible, services that won't have any conflicting models inside of them. If you cross the boundary, these conflicting models will eventually lead to a big ball of mud. If you follow the boundary context too strictly, you'll get monoliths, since there won't be any conflicting models in them, but they are still not microservices. There'll be independence between the contexts, for example, CRUD resources. But if you compose the boundary context further, you'll eventually find these sought after microservices. However, neither domain-driven design in general nor boundary context in particular do not provide any sort of proper guidance on how to do this. It's a very hard problem. A big monolith and a small monolith from domain-driven design perspective are perfectly valid boundary contexts, as they don't have any conflicting models in them. Therefore, microservice is a boundary context, but not the other way around. Not every boundary context is a microservice. And that's a very important thing to understand. Is if you go too far, you end up in monolith land again. So you've got to figure out how big or small your boundary context should be.
Distributed monolith, right?
Yes. I was trying to find a nice graph so everyone said it was too complicated.
All the benefits of monoliths with none of the advantages.
Yeah. So, outside the boundary context, language terms might have different meanings, and that's why we have this ubiquitous language to make sure that everyone within the boundary context understands all the sort of terms and language used. So, for example, does the article mean echo box, an auto-feed article, a sim-feed article, an article from a website? It's a very broad term. Stakeholders might represent the same business entity in different models, and a model is only valid within its boundary context. If you, for example, stand within the boundary context, you have two people stand in the circle of this boundary context, you all see the same definition, but if someone's sitting from the outside, they will have to understand your definition, but their version of an article might be different, so you kind of have to ensure that your ubiquitous language is concrete. Okay, so all the sort of boring definition stuff out of the way, we can look at finally, and you can have some nice diagrams to pick up. Patterns decomposing application into services. We'll look at two widely used patterns. Decompose by business capability, which organises services around businesses and business capabilities, and then we'll also look at decompose by subdomains, which organise services around domain-driven design and subdomains. You see, it's like surgery. Some people might get this, and it was horrible to look up this image. Okay, so let's first look at decompose by business capabilities. So define service corresponding to a business capability. A business capability is a concept of from business architecture modelling, where a business capability is something that a business does in order to generate actual value, and often corresponds to business objects. For example, article management is responsible for articles completely. Social management is responsible for all things social, and that's how sort of when you look at a business forest, you kind of break it up in sort of things that a business does. And that's sort of a way to decompose. So let's look at a snapshot of EchoBox. This is my version of decomposing by business capabilities. There are many other ways of doing it, but it's sort of a nice way of putting it in a presentation. So once you've identified the business capabilities, you'll define a service for each capability or group related to group or related capabilities. For example, you've got the EchoBox business object as a business capability, and it's focused on the EchoBox management capability, so you've got the sort of blue box around it. A capability often decomposes into its sub-capabilities, so for example, the order fee management and social management, and each of those can have their own sub-capabilities. So if we look at the next slide. I've decided to put optimal volume calculator management, new share management, reshare management, new order fee management. As someone from business, they might say that these are sort of things we need to manage. And in social management, we split up Facebook and Twitter management. It's sort of same social management. As you can see on Facebook, we decided hey, we need to do a Facebook management and a Facebook real-time update management. So you can have sort of sub business capabilities. And then finally, we map it actually onto the application architecture. The auto-feed components handle different phases, so it's best perhaps to have their own services, and we can treat Facebook and Twitter operations the same for now. Facebook can again be broken down to separate services, so that's a pretty simple way to break down into our different architecture. So that was pretty simple, hopefully. Again, it's all about identifying those contexts, which is hard. Again, it might not be the best way of doing it that way, but it was nice and shown in a diagram. So, a few benefits. It's a stable architecture. Since the business capabilities are relatively stable, businesses generally don't end up changing their capabilities. Something that generates value will always generate value for them. An original architecture evolves around how businesses change, but the underlying architecture never really changes. Development teams are cross-functional, autonomous, organised around delivering business value rather than technical features, if that's something you're a bit more concerned about. Services are cohesive and loosely coupled because they're all based around sort of their management roles. And it helps align business and development teams. But you see there are many issues. I've only put 2 on this slide, but there are many issues. An organisation business capabilities are identified by actually analysing the business's purpose, structure, business process, and areas of expertise. So if there's already something inefficient in the business, it's going to reflect in your in the way that you decompose your technology stack. If your business has sort of say, oh, do we really need an auto feed management? Someone says yes. You're going to create a service for it. Does that service technically need to be there? Are there inefficiencies in there if we've broken it down incorrectly, or if the business doesn't even need it? Is a hard problem. And businesses, in the end, they may evolve over time as we learn more about the application domain. In particular, important step in the architecture definition process is investigating how services collaborate with each other in architectural services. For example, you might discover that a particular decomposition is inefficient due to excessive inter-process communication. You must combine services together. And some will be like, whoa, but that's something that we do in the business as it is. So it might be difficult to change over time. And a service might grow in complexity, and it might be hard to break it down to different services. If part of an organisation breaks off, it might be difficult then to actually split that into a new service. So again, it has its own issues as well. And a bit more of a fun one, which is very difficult to do, is decompose by subdomains. So how this is different is we define services corresponding to domain-driven design subdomains instead of business requirements. A domain is the problem space, i.e. the sphere of knowledge, which in some cases, some people might consider it as also the business. So that's where these kind of two can merge and get confused, I guess. And a domain can consist of multiple domains, and this is how we kind of break and decompose by the subdomains. And each subdomain corresponds to a different can correspond to different parts of the businesses, and that's when you can make decompose by business capability but more flexible if you look at it from that way. But again, it's very hard to define, so we'll go through some ways we can define this a bit later on. So here we have lovely EchoBox domain. Again, we have the auto-feed articles, media sources, social, client setup, and other parts of the business, or as you say, whatever parts that you want to define your domain as. The boundary context includes the code artifacts to implement the model. When using the microservice architecture, each boundary context is a service or set of services. We can create a microservice architecture by applying domain-driven design and defining services for each subdomain. For example, let's look at the auto feed again. We decided, okay, the auto feed is its own boundary context and now it's its own subdomain. We have now defined ourselves an auto feed service, and we have an auto feed domain model. And then we go, I think the auto volume should be in its own domain as well. So again, we'll break it down further. and we'll have the optimal volume calculation service, and again within that we'll have the actual optimal volume calculation model, and so forth. So you can break it down within the actual domain. The subdomains domain model can be broken down further into other subdomains as necessary. And again, if we apply that to the same, we'll get that to look something like this. Again, it might not be the best way to do it, but it's something nice in the presentation. So, what's the resulting context? The pro of this approach that can lead to system design that closely models the reality of what's actually happening or needs to happen under the hood. Hopefully business structure already aligns with this, but where it doesn't, it can reveal inefficiencies in the existing business organization structure. Also the microservice architecture concept of each domain model being owned and developed by a single team instead of managed by a huge team because it's a business capability. Even better, the concept of subdomain with its own domain model is a way to eliminate goal classes. We'll talk about that later, which makes decomposition a lot easier. And so decomposed by subdomain and decomposed by business capability are the two main patterns for defining an application of microservice architecture. These, however, are some useful guidelines for decomposition that have their roots in object-oriented design. So we'll take a look at them and how we can decompose. Because it's nice having a diagram that kind of shows you how to do it, but there are patterns and different ways you can think about deconstructing. And again, we have some issues. How do we define the subdomains? It's a hard problem. You can define them by understanding the business capabilities and then decompose via that way, or you can look at sort of the technical issues that you have and decompose that way. So there's sort of different ways you can think about defining your subdomains. And the only issue is that it's an iterative process. You won't get it right the first time. You'll have to you create your subdomains and you go, oh, actually, I might decompose further into this subdomain, or actually this subdomain should be split into two different domains. So it's a very difficult problem, and again, no one really gets it first time. I've not seen someone online get it first time, so we're not alone. So yeah. Next slide. So into the meat of the topic, how can we determine the subdomains using domain-driven design? So here's a couple of guidelines that I found online. The single responsibility principle: a class should only have one reason to change. One of the main goals of software architecture and design is determining the responsibilities of each software element. Each responsibility that a class has a potential for that class to change. If a class has multiple responsibilities that change independently, the class won't be stable. Design classes in such a way that have a single responsibility and single reason to change. So you shouldn't be changing class for multiple reasons. It should have one distinct way of changing. And then finally you have the common closure principle. So the quote goes, the class and the package should be close together against the same kind of change. A change that affects the package, or the classes within that actual package. So if two classes change in lockstep because they're the same underlying reason, they belong in the same package. When a business rule changes, developers only change the code in a small number of packages. So you shouldn't really change things outside the package. If they do, then they belong in the same one. Simple. So as I teased earlier, we do have this nice thing called a context map pattern, and if you see this online, it's, I don't know if you're familiar with like brainstorming or like nice little spider diagrams, and that's a good way of actually mapping context onto your from your application. And we'll look at the ways that we can do that in a bit. And the way we identify boundary context is using context mapping. You can identify various contexts in application within their boundaries. It's common to have different context boundaries for each small subsystem, and as I said earlier, when you stand in the circle of your boundary context, everything in that boundary context should remain as a ubiquitous language. Everything outside of it has an understanding, but it doesn't really care about what's within that other boundary context. So hopefully we'll go through some nice examples of how Echobox can use this context mapping patterns. Cool. So let's look at some issues. Same term, different meaning. Let's look at a trivial example in Echobox. For example, we have this word account. It can mean many things. It could be a social account, as for example, I am a victim of saying our social account instead of social API. It could mean Facebook, Twitter, or even Echobox account as a property. Again, we rename this, but I still use the word account. Or it could mean a user account, and they all map to the same sort of account name. But they all could have different meanings, so the content max is designed as a primary tool to make the standard contract more explicit. The basic idea is to draw boundaries on the whiteboard, or blackboard in this case, ultimately filling them up with relevant domain terms and classes. It's not like a UML diagram, but it just kind of is a tool for like mapping a fuzzy situation to somewhat sort of fuzzy look is necessary. So let's look at an example. Thankfully, I don't think in Echobox we have this, but I just mangled this together. So same concept, different use. We have an account API, and then for example, we have this object called account. So this is the property in this case. The user account. And the user account has the ID, username, password, and you have all these methods. You get username, set username, get password, set password. Shall we use this class? Does it make sense? It doesn't feel right. Should an account API be able to change username and password? Probably not. Similar to sort of a bank. If you have a banking account and you want to pay a payee, should the payee account be modeled as the same as your own banking account? It will have access to the same methods, get money, deposit money, withdraw money from a payee account as well as your own. It doesn't really make sense. Are we solving code dupe, or are we actually increasing coupling here? So there's this thing called aggregates to the rescue. And aggregates, instead of using an actual object, will use the primary key rather than object reference. For example, you think about a car. A car doesn't really care that it has four wheels. It doesn't care that it has a steering wheel. All it cares about is, can the car move forwards? It just has to have a reference. Has to have the primary key rather than the object actual reference. So that's a way you can kind of put it. And aggregates are a collection of objects that are bound together by this sort of root entity, an aggregate root. An aggregate root guarantees the consistency of changes being made in the aggregate by forbidding the external object from holding references to all its members. For example, in the case of Echobox, media item source doesn't really care about other attributes, articles, sim feeds. If they change over time, it doesn't really. It just cares about holding the reference to an article in a sim feed. So thankfully in Echobox we are using aggregates. That's nice, but it makes sense that in the case of code dupe, not really. So in another example, same concept, different use. A more puzzling distinction might arise when underlying concept is the same, but used in different ways and eventually to different models. We don't actually know the internals of the models and the objects and the operations. Does it make sense for one model to be put against another? Well, it doesn't sound reasonable after all. It's kind of the same concept, right? So, for example, here we have the API context. An API has, we have fields, average traffic, last seen item. And here in this case, we use APIs as social APIs, and we have traffic APIs. Does it make sense to use them in the same context? So we can break this down. An account API is used as a social context and a GA context. You have the last thing identified that's not actually used in a GA context. Doesn't make sense. And again, the URL cache is used in the GA context, but not in the social context. It doesn't really make sense to kind of use them under the same bounded context. So, we can end up breaking these into separate different contexts in the end. That's a relatively simple example, but there are much difficult ones to do. Cool. So this is sort of what a content map kind of looks like at the end. You have your sort of your different contexts, you've got your socials and your articles, and they live in their own little bubbles, and they're sort of connected. They have a sort of relationship. They're connected with these sort of lines. So say if two models are designed to represent the same data, they're different, which was subject to different evolution forces over time and serve distinct purposes. Thus, separate bounding contexts are needed. Nice hand-drawn circles. So, how do we manage multiple contexts over time? When our application spans multiple contexts, we need to manage also what happens in between. The relationship between different bounded contexts can often provide very important insights about our actual project itself. One of the most important things we need to know is the direction of the relationship between two contexts. So domain-driven design uses terms of upstream and downstream. An upstream context will influence the downstream counterpart, while the opposite might not be true. This might apply to code, but also less technical factors such as schedule or responsiveness to external requests. So in our example, this new service comes along and it joins our sort of context map. Our system clearly won't change according to our request, while our for example, the articles might have to be updated quickly in the case the new service decides to change the API for any reason. So in this case, I've given an example of articles is downstream and new services is clearly upstream here. Nice UD, you can see. So we can accept to update the way we communicate with the external system or external demand, but we probably need some sort of protection against coming from the upstream context, and we should preserve this sort of conceptual integrity of our article context. So domain-driven design describes the several organization patterns that help us manage how different sort of contexts interact. For example, if the new service decides, I'm going to change my format from, I don't know, this JSON body that I usually send, but I'm going to remove a couple of fields because they're no longer needed, and I'm going to add some new ones. And there are several patterns here. I won't go into detail because it's not part of the presentation, but it's sort of a nice sort of way we can manage is this sort of anti-corruption layer, which calls for an explicit translation to happen in the code level between the two contexts. So we need to sort of protect ourselves in case a new service decides to change for some reason. And there's sort of many ways to do this, I won't go into too much detail. So we draw this new anti-corruption layer onto our context map here. So another example of this context map. What happens when we decide to scale up? For example, maybe suppose EchoBox gets bigger, and therefore a new team is created. In this case, this media team. Media could end up sharing the same code as articles. After all, code dupe is the root of all evil. Or even writing code that is sort of available in articles. In a single well-defined bounded context, it can happen, but for some reason it doesn't happen most of the time. It's non-trivial on the project.
I would just caveat that by saying code dupe within a bounded context is bad.
Yeah.
Code dupe in separate bounded contexts is actually a good thing in microservices.
So this is normally a sign that there are probably not so well separated contexts in play or the same area in the project. Sometimes this will make two separated contexts more efficient way to structure our domain model than forcing two different teams to continuously integrate their own visions. So how do we draw this on our map? Concept maps affects our current level of understanding, and the whole system will be updated as long as we learn something more and the environment changes. Currently we don't know exactly what's going on in our current level of, this is our sort of current level of understanding. This new media team has just joined, so we're not too sure what's happening. So we've added a caution sign there. If all else fails, add a caution sign to the diagram that there's something not right here. The two contexts partially overlap and the relationship isn't entirely clear, so we might need to go back and discuss what the relationship between this new media team and the articles, this new media context and the articles is. And this is probably one of the sort of first issues to solve. Try to set up an agreed and sustainable relationship within the context. Like between the media and the articles. We need to sort of have a clear sort of definition between how articles and media's relationship works. But again, that's tomorrow's job. An article on text is a tool for now. Is probably the problem's still open, so we'll leave the caution sign in the diagram for now. So hopefully you have a bit more better understanding of sort of using the context map to define a boundary context and to remain within a boundary context. We'll just look at some obstacles with domain-driven design and boundary context. We have network latency. It's always going to be an issue within a distributed system. You might discover particular decomposition services makes a large number of round trips between two services. You can reduce this latency by implementing batch APIs, caching, fetching multiple data in a single round trip, but sometimes you might have to combine services together. If you're concerned about latency or those kind of synchronous issues, it might just be better off in that case to accept defeat, and two services might have to just be merged together. And then another issue is synchronous communication reduces availability. Another problem is how to implement this inter-service communication which does reduce availability. I don't know if someone might be doing a talk today about it. So a most straightforward way to implement and create operation services is simply invoke other services, for example using REST. The drawback is it reduces availability of that service. For example, if one goes down and they're all synchronous, you're kind of screwed if you don't get your result back. You can't do anything else, right? It won't be able to create any other thing if one service is unavailable. Sometimes it's worthwhile, but there are asynchronous ways. It's more difficult, but it eliminates the tight coupling between services and is often a better choice. We have data consistency issues between services. Another challenge is maintaining data across services. For example, system operations need to update on multiple services. When an article is texted in SIM feeds, updates must occur in both article service, media items, and so forth. And they must be done atomically. If they're sort of, one has to a certain two-phase commit, right? You update one, then update the other. It might be difficult to sort of orchestrate how these updates happen if you do them sequentially. So it's not a sort of good idea to do this in sort of the old school ACID transactions. And I think there's probably a talk on it that can solve this issue. And then we have to have a consistent view of the data. So another issue with decomposition is that you never really obtain a true consistent view of the data across multiple databases. In a monolithic application, the properties of ACID transactions guarantee that query will return a constant view of the database. But in a microservice architecture, even though the service database is consistent, you can never actually obtain a sort of global consistent view of the data, so all the data is sort of fragmented into different services. If you need a consistent view of some data, it must reside in a single service, which can prevent decomposition, unfortunately. Usually we can find ways around this. Ideally, you don't need to have a global view of the data, but then if you do, then maybe it's a good idea to go back to the drawing board. And finally, bug passes, bane of our existence. Take the water view, for example. It does a lot of updating between many tables and does a lot of stuff, and it's hard to separate. It's kind of like a headache, and it's in general all tightly coupled, right? Much better approaches apply domain-driven design and treat each service as a separate subdomain within its own domain model. It means that the services in the application that has anything to do with, say for example, articles, has its own domain model and its own version of the article class, so then it goes and does its own thing with its own model. So that's sort of a way to get around these sort of core classes. And again, there's a lot of sort of theory behind it, but omitted. So in conclusion, it's a hard problem. I hope that's your main take when you haven't fallen asleep. But there are many ways to have a problem and define its boundary context, for example, using a context map, looking at different relationships between different contexts, and hopefully that can help you solve the issue. Boundary context while defining sort of safe harbours, allowing models to grow in complexity without sacrificing sort of conceptual integrity. For example, if you use a context map, it shows sort of these implicit boundaries between that exist within the organisation that you sort of never saw before. Sort of it provides sort of like a snapshot of like the stage upon where your project will strive, hopefully. So yeah, if hopefully you don't work against the project's own success by breaking them down into bounded context, and we sort of need to define at what point do we stop breaking them down into becoming distributed monoliths. We don't want these sort of services happening. And then hopefully if you haven't fallen asleep and you don't want me to repeat slides, there's a Q&A.
Thank you very much. We've got about 10 minutes for questions. I'll kick us off. When you were talking about the anti-corruption layer, I didn't quite get what the takeaway was, because why did you have to introduce the anti-corruption layer? Because of the new service?
It's just in the case of the new service, if the new service decides to change what it sends downstream, you need some sort of way that you will protect yourself from any sort of changes that come from upstream. The upstream is never going to change because the article changes itself, and again the article shouldn't ever change because the new service decides to change some sort of the message it sends down to the thing. So we need to sort of make sure that if any changes happen that affect us,
they still get interpreted correctly.
Yeah, and there's loads of different ways. For example, they decide, I'm going to send all my JSON now to XML. We have to make sure that we have some sort of layer to make sure that we're always. It's a hard problem, like you said.
And I am my talk like that as well. So.
Yeah. Any other questions? I probably fell asleep. So.
I have a question. Is there any sort of advice that you found on how to iterate through these processes? So, as you said, you don't think it's right the first time. Was there any advice what to do when it goes wrong?
I think it's to make sure that your sort of, for example, the context map is flexible. You can add. You have to sort of define your relationships, and if a relationship doesn't really work, or something, one of your sort of bounded context doesn't really make sense, can it be merged into another, should be separated out. I think you kind of have to, again, the example was like use a whiteboard and actually just draw it out and go, the context map will change over time, and I think you just kind of have to accept it and make sure that your, architecture is flexible in such a way that, things can be broken down further, or new services can be added around.
The advice I've come across for that as well is start breaking things out from the edge first, and then move inwards, and that's referred to as like the strangler pattern of going to microservices, and also start big in terms of your service definition. So if you say your bounded context is the largest you can be, start off with bounded context, and then when you're iterating, work out, okay, do we have the right boundaries between the services, yes or no? If we do, then you can actually start looking within the bounded context and say, now how can we split that up into smaller services, and you can repeat that process. And I think Joanna mentioned it, it's valid to recombine services if you realise you've introduced if actually the same services have the same context for models and things like that. So.
Any other questions? Would you like to repeat anything that you missed? Or no? Okay.
I thought of one other thing that might be worth mentioning. So, yes, I'll start with the question. How do you think we would best split up the Ecobox platform into microservices via the domain-driven design or business capabilities?
I think we're more veered towards decomposed by subdomains, only because there are so many parts of Ecobox that isn't really visible or generates any value for the business. For example, say, I think of one off the top of my head. the parts of traffic, for example, business don't really care about the URL caches or anything extra that we do for sort of traffic. Everyone kind of on the business side goes, give me the numbers for clicks or whatever. I think there's a lot of stuff underneath EchoBox that aren't necessarily that generate any value, but are integral to the actual workings of EchoBox.
Yeah,
I think,
yeah. I get my terminology mixed up sometimes. I say bound context, I mean subdomain. I think I agree, and I've having thought about this, I can only really see one business capability within EchoBox. We don't have multiple business capabilities. We sell one product to one vertical, and the goal there is to allow publishers to schedule on social media and automate that task for them.
Yeah.
And then I thought, well, what might a new business capability be? And an example might be, say we started selling tools that interact with social media, but the goal here is purely ad based. Where maybe the customers are no longer publishers, they're brands. So we now have two potential subdomains, both of which interact with social media. And you might say, if we were going to break things down by subdomains, we might have shares for publishers and the advertising API calls all within the same service.
Yeah.
It's all interacting with Facebook. But if you then said, well, actually it makes more sense to break it down by business capability, you could say, well, the service that interacts with Facebook for ads is going to be completely separate and independent from the service that interacts with Facebook for social shares. And I can see there, actually, it might make much more sense to keep them separate, because you don't want the capabilities of one to be held up by developments and issues in the other.
Yeah. I mean, the nice thing about the subdomains is that you can actually define subdomains kind of by business value as well. It's up to you how you define those subdomains itself. It can be business generating as well as sort of technical as well.
And that's when I was talking about code dupe as well. Someone might look at these two services and say, well, actually, there's a significant amount of code duplication here. But because we've essentially said, well, they're going to be separate, that's not necessarily a bad thing. And one can now evolve entirely independently of the other. Cool. Any last questions? Awesome. Well, thank you very much for starting.